Okay, guys, so delta math powers of I. So here's a couple example problems in case you're getting lost with those. The biggest thing is, I think, from the questions I received, is making sure that you realize that 2, 11, 4, and 9 are not something you're going to deal with off the bat. You're going to kind of leave those be and then come back to them. So we're going to take the first one, which is I-99, and then we're going to deal with it. Then we're going to do I-24, I-39, and I-13. And then we'll get back to all the goodies that are up there that might make this look a little scarier. So 99, you're going to see how many times, because the powers of I, so I is the square root of -1. I squared, which means square root of -1 times the square root of -1, because that's what squared means, equals -1. I cubed is going to be the same thing, so square root of -1 times the square root of -1 times the square root of -1, which, remember, oh, looks, that one kind of got a little crazy, sorry, which is -1 times the square root of -1. The square root of -1 is I, so this is going to be a -1i or -I. Then I to the 4th is the same thing, so it's square root of -1 times the square root of -1, which we already know is -1, times the square root of -1 times the square root of -1, which we would say is also a -1, and a negative times a negative is going to give us a +1. These 4 are the 4 you're going to use repeatedly. And the easiest way is to try to get rid of as many sets of 4 as possible. Because remember, I-99 means there's 99 I's written out. And if you break down how many sets of 4's you can get out, that's how many 1's there are. And 1 times 1 is 1. If I did 1 times 1 times 1 times 1 times 1 times 1 times 1, it's still 1. So if we take it at 99, we're going to divide it by 4. It is not an even number. It's going to go in there 24 with some leftover. And then 24, if you're following Delta's instructions, you're going to see that it says I-96 times plus I-3. So this I-96, these are sets of 4's, because again, that is going to be 4 times 24. So that equals 1. So it's 1, and then I to the 3rd. I to the 3rd, we just realized, is a -I. So this is going to be a -I. So if we're looking at 2 plus 11 plus 4 plus 9, and we've pulled out all our I's, these little parentheses are what we're working on up here, then that first I-99 is going to be 1 I to the 3rd, and I to the 3rd again is a -I, so 1 times -I, so this is going to be a -I right here, because that's our 99I. Now 24 divided by 4, it does go in there 6 times, so that means that I-24 is it, so it's 6 times 4, so I-24, which means it's going to be a 1. So if it's a perfect multiple of 4, then it is done. It is just 1. That's it. There's no leftovers. We don't have to account for anything. So that means this one is going to go right. 1's going to go here. I-39, so 39 divided by 4 does not go in evenly. So we're going to do I, and it does go in there 9 times. So 9 times 4, which gives us 36. So I-36, and then we have I to the 3rd left again. This 36 is 9 times 4, which means it's going to become a 1, because that's even sets of 4. So that means 9 chunks of 4 I's. So it's 1 times 1 times 1, 9 times. So that's why it's 1. And then I to the 3rd is that -I. So it's going to be -I again. So for our 39, it's -I again. If we go ahead and look at I to the 13, so 4 will go in there 3 times, so it'll be I-12, right? So because that's 4 times 3 gives me 12, so that's going to turn into a 1. And then left over that 12 is just I, so the 1 power, which is I. So then we have 1 times I, which just gives us I. And so the 4th one is going to be just I. And then now we're going to do our math and combine where we can, or fix where we can, and leave it and turn it into a complex number. So this is going to be a -2I plus 11 plus a -4I plus 9I. And now you're combining like terms. So your I's are all like terms. So this guy, in this guy. So negative 2 plus negative 4 plus 9 should give us a 3i. And then we have 11. And 11 is just by itself. It is as constant as is. And then so it's 3i plus 11. And that should be your answer for that guy. All right, guys. There's more to come, but there's one example.